Good night, people. It's time to get started, so let's get going. So, ROM monitor. What is wrong with you? Okay, I will have to fix it, guess. Screen capture. Properties, change the screen, done. Okay. There we go. It's too bad I cannot edit it without switching the screen. Anyway, in the last time we was starting to load this test suite that is make some sort of unit test on the fly, so I can load this ROM, follow some requirements to print the state of the CPU after every instruction or before every instruction, and that will making that print, it should result on the same string shown. So I start doing that. We are creating the trace of the output. So we have an output. The first 4 digits are the memory address of the program counter. Then we have the opcode and the arguments of the opcode. Hey, Alam Lima, welcome to the stream. Thanks for the follow. So then we print the opcode and the arguments, and then the disassembler of such instruction, and final information about what is the memory that is being read or write. Then the state of the registers, and finally the states of the of the PPU and CPU. We yet don't have a PPU, and we don't track the cycles of the CPU, so we are not going to do that yet, but we are going to make these first 5 blocks. And for this purpose, we have created our trace method that is going to print program counter. It's appending the instruction and the arguments, and then now I am working on the dump of the disassemble of the function. Dumping the disassemble is going to take the instruction. It's getting the address and the value of the address for the addressing mode of the instruction, and now I am looking at how it should print every single example of every single addressing mode. So immediate is just a hex value that is hard coded, and this number means it's a literal. 0 page is just 1 byte. 0 page X is 1 byte plus X. So we are going to say $, X, and then what is the address and what is the value that we are accessing. For 0 page Y, we do the same. For absolute, we are making a dump of two addresses. So for little endianness, we are printing first the second argument and then the first argument. For absolute X, it is kind of the same of 0 page, except it takes 2 bytes instead of 1. And for indirection, we use parentheses, and it shows what is the address and value. And in direction X, the X is inside the parentheses, and in direction Y, the Y is outside the parentheses. So we have not yet seen how this goes, but we can try to run it. So on init, we are loading the unit test file from this path and starting running, hopefully. So let's see what do we get from printing these instructions. Nope, wrong scene. This is the snake game that we have been doing, and it's running from an NES ROM file. And this is the actual test. So we could not get an operand address for this addressing mode -1. And which is -1? Why is it using -1? What is the instruction? It's set E. Okay, it's because it does not have any addressing mode. Okay. So let's do this. Address and value are of type integer and equal to 0 by default. And then if the addressing mode is different to -1, we're going to make this assignment. Does that help? Let's see. Rerun. Okay, we're getting a lot of prints of a null value. So trace is not returning anything, and that is why it is printing null. So let's make sure this outputs string always. And let's give it another try. And now we are getting some prints. So we can take to the top of it and see how good we are doing, comparing to the file that we are meant to be loading. So let's show in file path, and in here is the file that we are meant to be comparing with. So let's see how it starts. So I don't like this. It is starting. It is not. Wait a second. It is executing totally different instructions from what I see here. And it's also not starting on the same address. Why is this starting on C4 instead? So let's go back to my script and take a look to the first trace in first place. And when we return, let's return it to upper. I will change what is the scene that is run by default to avoid making that silly mistake. So let's run this one now. And what we are getting, so this is the first instruction. the program counter, let's take a look. The program counter is set to this value. Let's see what is it on hex. It is indeed C004. So question is, why is that happening? What happened to the previous instruction? So we are running. We are executing run from here. We have just called reset, and we are setting the value, the program value, to whatever is in this memory location on start. So for the unit test, we are creating an NES memory, and on init it is supposed to, what is init? Memory size and reset. This calling reset. Reset is calling super. And super is filling the memory, but I don't see anything setting the initial value from here. And does it happen on the NES CPU? So it is setting this value, but where is this value being set? So when loading the program, it is setting the value, but we are not calling load from there. Now we are using a different mechanism. So maybe that is the issue, because now we are just setting the ROM directly. So we could try to do it by hand. And as we was saying, the code should be started at this address. So let's see what happens if we change this. I think that they are supposed to be the same address because of shadowing memory. So did something wrong. Okay, I could not write the memory. Okay, yes, I see why. Because we are not calling the function in this code. So how do we fix this? Why I have lost input? Yeah, I cannot stop it. That's weird. Anyway, let's just reload the project. Here we go. So the reason why we cannot write here is because this reading does not take into account this part of the reading. So it would work with a usual memory, but not for the NES memory. So the NES memory needs to implement memwrite 16, I guess. address, integer, value, integer, and let's see how was it before. Bum 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 bum. So now we have an override that we can take care. When writing memory, we need to make these operations with the memory. So how do we avoid the internal call? So how about this? Func memread address int p observe boolean. So in here we can call it passing observe as false. So then we only emit if observe is true. So this way we can read the memory without causing issues. Yes, this should return. Okay, I like this. I like this approach. So we can do the same in here. And in here we can use memread with the address and false. Wait a second. This one is meant to be true. This one is being observed, and this one is not. Address plus 1, false. So what value missing parentheses? So now we are going to do the same with be observed. No, wait. But I think we don't. Let's not overcomplicate it until we need it. For now, we don't need to write. Actually, maybe we do. But let's not care about that yet. So let's see what happens now. Do we crash? Okay, it's not crashing. So let's stop and go to the top and see what is happening this time. So now we have the same start from what I see. So where is the log file? Here is the log file. So for some strange reason, it is not starting on the address that is meant to be. We're getting a lot of we are doing a lot of incorrect stuff. So let's find out what we are doing wrong again. So we are doing init. And what are we doing after init? All right, we are doing rested. and reset is overwriting that function. So let's do this. Let's make, wait, this is not the right one. So instead of taking this, let's override reset. Let's call super and then set the memory address to what we want. And what happens now? Stop. And let's take a look. We are still starting on the same address. That's quite interesting. So let's take a look from this point. So here we are calling reset. We're restarting the things, and we are setting the program counter to the contents of this space. And now the program counter equals to this value. And where is my calculator? Again. So the value is indeed C004. Question is, why is it C004? When is it being set? Let's try to check on that. And for that, we could try to make an observer. Hold up. Memory, create memory observer, and we want to check this memory if I recall correctly. Is that right? FFFC, and it was the opposite. OX FFFC, and we want O. It was memory observer, observer flags, read write 16, or memory observer flags read write 8. So we are basically checking everything. Memory observer equals no. Let's assign it and connect some signal. Where is my music? Okay. Back to the do. So we have memory write, connect, on observer memory write, and what are the arguments for this? So we have address, old and new value. Func observer memory write, and all these arguments. So let's say print push warning did write on memory let's just use before, after, and we can say address, old value, new value. So let's see if we can find what is happening here. What are you doing? Address is double S. So are we getting this? Advance, pause. Did we get this warning? Seems not. So let's try this is annoying. Sorry. So let's try memory read, and let's see. Let's try to make the same check for memory read. Value and connect the signal. It's on. Duplicate memory read on memory read, and let's see what happens now. Let's put breakpoints, it will be easier. So it is reading the memory straight away without writing it, unless that whatever write is being done is done directly on private. So we are reading from address FFFC the old value, a new value is 4. Oh, okay, so it's 2 bytes read. So it is making mem read from here. And this mem read is coming from this mem read that is not using false. And that's why it is being emitted. Well, I am not yet concerned. So let's advance. So we have low and high memory. And low is 4 and high is 192, which is OC. So question is, why is the low byte a 4 instead of a 0? When are we setting this value? So something we could try is to change this memory read and memory write to pass through instead and see if it's being set. Okay, we're still going strike to read. So result is again C4. So question is, why is it being set to that value? So if I do a bar start equals memory mem read 16 0x000F, it is going to return me. Okay. What is wrong with you? So address. Seems I cannot access this address at this point. And why is that? So we're trying to get memory low. We're trying to read the memory at address. And it comes from the ROM, and we have not yet set the ROM, and that is why. So maybe the issue is that we are loading the ROM at the wrong location of memory. That doesn't make sense. So ROM is null, that is why it is not loading anything. So we cannot fetch the value in here. We can only fetch it after setting the ROM. So what if we do this? If we do this, now the ROM is being set and start is this value. that if we convert stupid 49156, and it is indeed OC004. But why is that the value? Let's see what it does when we try to read the value. So it is getting the address, we get inside, and it seems to be inside of the ROM memory range. So we enter and says address minus ROM memory start. So question is ROM memory start wrong? Let's see how is this written. In the previous chapter, what is ROM memory start? So it creates a bus with a new ROM, sets the ROM, and it reads, and when it reads, cannot write, and it reads, and it subtracts 8000, just the same as before. If ROM length equals 4000 and address is bigger than 4000, so let's see what is proc ROM. It is 16384, which is 16384. Oh, this is hex. 16384. It's indeed 4000 hex. So it's less or equal. An address is bigger than 4000. So indeed is redirecting the address. And now address is 16380. 16380. Oops. And that is 3FFC. But what is important is that the ROM program 60, what did I say? 380. So it is indeed a 4 in here. A 4 and a 192. So what is wrong in here? I don't get it. Am I crazy? What is going on? Let's take a peek to how it looks on the GitHub and see if we find something wrong. So cartridge, we have mirroring, we have size, we have the tag, program ROM, we have new, mapper, version, full screen, vertical, test room, header trainer, th room, with capacity, so we have header length, trainer, th room, extend, create ROM, test ROM, create ROM, and it is choose some random values. I see. So it's hard coding a ROM with some values without using the NES ROM, and that is because we are on the previous chapter yet, so it makes sense. What if we look at the next chapter? Will we be getting something else? So we have the log file, and it indeed starts at this value, and the NES file. So is it possible the NES file is broken? I don't think so. So we have trace.rs. Pum pum. Xdump. Push code. So yeah, so this is how it works. Okay, so it's 0.2. Interesting. Maybe that helps my prints as well. Maybe I can replace this by %02x. Replace all, and let's just see if it changes or not. Indeed it does. And we are still starting on the wrong location, but at least we are printing the values correctly. So question is, why are we starting on this value to start with? Is the NES room being read wrongly? NES ROM. So maybe the slice is not correct. Let's take a look to that. If we look at praw, it should end So we have program room start is 16, correct? It does not have a trainer. So slice is begin is inclusive, end is exclusive. Sounds about right. Doesn't make sense to me. It doesn't work. So in theory, if I make I don't have an undo. Program start is 16 and size is 6384. 6384 plus 16, and that is where it ends. 16400, but it does not have that much, does it? Oh, it does have a chat room. Okay, so let's go somewhere on the hub. Yes, 700. Couple more pages. So this is the end of the file. I mean, this is the end of the program section. And what is ch room start? This 600, 400, 16400. Wait a second. Oh, I am still wrong. Pam pam pam. Okay, here starts the chat room, and this is the last part of the program room. And indeed, it says a 4 in here. This looks about right. So why is it different? Do you have a broken NES file? It is doing what it is meant to do. So where is the cartridge? Mapper version program room size is raw 4 times. So are we doing raw 4? The size is program room index 4. Yes. And the page is 5 times. So this is about right. Keep trainer. Program. I don't see any mistake. But let's see what happens if we download this raw file and replace it. I have no other thing to, any other idea of how to do it. Replace and retry. So now the program room it's still the same. So what are we doing wrong? I don't get it. This should be 0. Doesn't make sense to me. It's not 0. If I change it to 0, what happens next? Addressing mode is not supported. And what happened before that? We got a lot of prints, and it started when it was supposed to start, and the first instruction seems to match. Jesus Christ. Let's open the log file. So we have jump, ldx, set, JSR, no op, sec, BCS. So BCS is not supposed to write this. And branching, no ops, DLC. BCS again, jump. No, sorry, it's the opposite. BCS is supposed to print and it is not doing it. And why is that? So we got a good start. And where did this break? Addressing mode is not supported. Mode is 7. Instruction. And what is 7? Let's take a look. 0, 1, 2, 3, 4, 5, 6, 7. 7 is indirect. So I never implemented indirect. That is it. Ah, I see. Yeah, so I hard-coded indirect in the only instruction that used it. Indirect. So what if I add it in here. Indirect. So we have address, we have the address. And then something like this. Does this work? What is wrong now? Could not resolve. And why is that? I broke something. Oh, I did not return in here. Maybe it's that. So we are making the slice. And after the slice, let's do the same experiment of taking sub, program ROM, going to the end, and changing this 4 for a 0. And let's continue. Now we got a null instruction with opcode 4. And there was something about that possibility, because if we look at this, it says you can use div2 blah blah blah. If everything is okay, the first mismatch should look like this. Everything that our emulator has produced should exactly match Godot startup up to line C6 BC. No, we are not yet there. Or maybe we are ahead. Can I search? C6 BC? Nope. We did not get it there. So something went wrong in here. Don't know. I don't know what yet. But the thing is, what are we doing wrong? Maybe I should not read the value from the memory when inserting a cartridge. That doesn't sound right. So this one is not trimming the space. Cannot use get node. What? That doesn't make sense. did write a value. Calculator, what is the value? 49152. Okay, something is writing in here. And what is it? Okay, it only worked because it was copying the value that I hard coded. Oh boy. So it is still strange. Why is it? Oh, because I did not change write for read. So did read on memory the value. So this is still strange. What am I doing wrong? Let's take a look. Maybe it's on the bus. Pa-pa-pam, pa-pam, pa-pam. So where is the ROM? Program ROM, lower bank, upper rank. And so the upper bank equals to the lower bank. And it goes from 8000 to C. Calculator. $8,000 plus 4,000 equals, wait, this was meant to be hex. 8,000 plus 4,000, it is 3,000. So it is virtually the first instruction in the program memory, which makes kinda sense, I guess. So bus, new bus, ROM, red program. It makes minus 8,000. I think yes. NES memory. Ba-bam. Minus 8,000. Yep. If len is 4,000 and address is bigger, from program address. So address is 16,380 3FFC. Why is it 3FFC and not FFFC? Memory read, FFFC, read address. Address is 65,532. What is it? 532, and it is FFFC, correct? And it is minus 8,000. 7FFC. And because it is bigger than 4,000, it is minus 4,000, 3FFC. So indeed it is correct. 3FF6, 16380. And if we look at the ROM, (16380) is indeed a 4. So I am confused. I simply don't know why is this happening. Reading, memread, blah blah blah. Self-read program ROM, address, memwrite, don't write to address. Okay, so let's see what the CPU does on reset. It has read, it has write. And it just reads and writes to the bus. It sets the status by default. Interesting. The default is not 0. Get absolute address. Get operand address. Pa-pa-pum. So let's check what it does. Load and run. We have program, load, reset, program counter, run. Oh, it is setting program counter to 0x6. That's strange. What is this NES log you said? Reset. Program counter is being read from this memory. And it is using memory write. Holy. I don't like this much. It was not mentioned at all on the tutorial. Is this CPU being used? What if I search? Can I search? No, it only search files. Trace. So this one takes a CPU and makes the dump. Test ROM. Cartridge test ROM. This is making not use of the cartridge of the ROM file. So snake opcodes. Main uses a cartridge. Does it use the NES file? Okay, we have a read of the file. It's making a new ROM from the bytes, and it is manually setting the program counter. Well, okay. I don't remember this being mentioned. Maybe it was. Okay, so I will not become crazy. I will just get rid of this stuff. No need for the observer anymore. We just figured out what was wrong, apparently. Now we can set this program counter manually. And now we can keep moving, and we have our first assertion in here. So there was a couple of attempts of writing the cartridge. So let's see, where is that happening? So what is the address? 65. The instruction is store A, and it is trying to store A using addressing mode A, which is indirect X. So let's take a look to this. Let's advance on the test, actually. So now, instead of printing the trace, let's emit a signal. Signal instruction traced. Trace It's going to be a string. So in here we are going to emit the signal. And now we can connect to it. CPU instruction tracer, connect, on CPU instruction tracer, funk, and we are going to get the trace as a string. So the other thing we need is our file, log file of type file, access, log file equals file access dot open. Actually, I think we can do it directly on here and use the log file constant over here. For read permissions, wait a second. There we go. And this is like this. Assert log file not null. So now every time we get a trace, we are going to compare with of type string, and it's going to be log file, it's get or read, no, get line. So if ptrace not equal to compare with slice, no, it's not slice what I want. We want left and the length of the ptrace, and this is because we are cutting the string on whatever is the length of this. We are going to push error or push warning. Let's log the bug maybe. No, print the bug, yes. Trace mismatch. New line, a tab, and we have log is going to be this, and a new line, and a tab, and CPU, and a second argument. Now we are going to pass first the compare with, and second the ptrace. So left makes what? Oh, right, it's ptrace length, not ptrace. Okay. So now let's take a different look at this. So we have a bunch of mismatches. The first one is this one. Since we have a missing space to make stuff match better. So, okay, so why are we saying it doesn't match? Because we are supposed to be comparing only the first part of it. Compare with equals this. So now let's see, why is it saying it doesn't match? Jump C5, F5. So length is not correct? Is that it? Why is it much longer? Does left not work like what I think? Oh, it is removing the last. That is dumb. And what of substring? From 0 to length. And let's see what happens now. So the match is compared with it is kinda doing the same as before. From 0 to the length. The trace is 1, 2, 3, 4. Well, whatever is much shorter. So what is it doing now? So apparently length is not what I think or what I want. But if I say len and pass the string, is this changing anything? Trace length. And what is it now? So length of ptrace is 49. And why is that? Okay, it's longer than it seems to be. So that could explain it. So it's probably a mistake on this part. Pa-pam. So if I look at the log file, it stops on 49 and starts in, let's see, yes, it's one before the mnemonic. So it starts on 16, 49 minus 16. It is 33. So let's try to do that, because when it could, it actually could on the A in this breakpoint, right? The trim indeed has the A, which is not correct. So that seems to be the reason why. So let's move on. Now we have different mismatches. And yes, I was expecting this kinda. So this is literal. Where is the trace? Instruction. Immediate. And immediate only reads 1. There is no need for this. It reads 1? I guess so. Yes, it cannot read more than 1. That's stupid. Still getting the same amount of mismatches, more or less. So now we have the BCS, the BCC, all the branching ones are getting this issue apparently. And that could be because indirect is not right. So let's take a look. The instruction is FO. So what does FO do? Branch equal, branch if flag matches. It does not make. Okay. I see what is going on. So it is not using any memory addressing, but because the callback is branching, it is adding this print. Then how about this? If instruction mnemonic begins with B, branch instructions. Actually, this should be the case if it is -1. So S out is going to be the same as absolute, right? Branch is always absolute. Let me check on that. Address, read value, blah blah blah. So let's copy this and let's paste it here. Address, we are going to take the value, we are going to read, we are going to make this operation, and address again. It's going to be value plus jump. And now we can add our dump. Actually, did we need this? Probably not. What does it print? It prints the actual memory or prints the actual next memory or prints the address where it gets it from. Let's take a look over here to the first PCC 4747 and goes to 4744. So it's this minus 3. This one matches. This one doesn't. Probably because it did not branch. Okay. So it's the actual memory location. So yes, address is what we want. So let's do this. Bum bum bum. For address. So how does that go? I suppose it did not work well. C9, 40, C9, 45. Now we are getting a very different value. Right, so do we have a line number? Trace mismatch on line D. Do we have no? So line plus equal 1, and we put line in here. So let's take a new look. Line 234. Bum bum. It did not go that far. This is not at all 235. actually. Oh, it starts counting from 1, not from 0. Duh. Makes sense, makes sense. Let's move that statement to add first. So now it is line 235. 235. What was the previous instruction? Branch not equal. It was supposed to be this PSB on address 940, but it went to 945. So branch not equal failed. So let's copy this and let's go to branch not equal in the NES CPU. If jump equals this, let's try the hard way first. Breakpoint. Okay, it did not work. So that number is the number that was meant, and this number is the number that was got. So let's say in, and we pass both of these values. After this change, and let's see what went wrong here. Wait a second. C940. Maybe it's 8. If it is using the upper bank, that could be it. Nope. Oh, it's plus equal. Okay. So it's program value plus. Can I do this? Okay, now I got a breakpoint, and we still have no debug. So yes, this is the case. So we have that the flag is the 0 flag, because yes is flag not equals false. Flag is false and it matches, so the address is, we read the program counter, we get the memory from that program counter, So let's try to do this. Let's repeat the process. And let's see where did it go wrong. So program counter is blah 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 51. Let's take a quick look. C93F. Let's see the log file, and it is indeed C93C. Right, but it also has a couple more. CDE. That doesn't make sense. I am making something wrong. So I did not change program counter yet. So address is gonna be that value, and I am going to read from that memory address. And jump equals to 5 to 6. And the reason of this failure seems to be because it's reading from the wrong memory, I suppose. So the mistake could be a carry from the previous lines. So let's try this one instead. Let's change how it prints, and let's make a push warning, and else let's just print the same. Trace match. So now, what do we have? So it was failing online. Alright. So now we got the first failure, didn't we? No, this is not the case yet. So it was line 233. So let's change a little the overflow. Print. There is no limit for print in here. Is it in here? Interface, debugger. I don't like that. So we could make the no op wait a frame and see if that fixes the problem with overflow. Or we could say in here when emitting. Counter plus equal 1 if counter modulus 100 await engine get my loop idle frame. Is that correct? Right, equals 0. It's underscore counter. Right, is process frame. I'm sorry. Yeah, just move on. And did we get better prints? No, same issue in the same moment. So instead of that, we could because it seems 183 is the limit. Let's use 180 and we are going to create a timer of 1 second. Timeout. Okay. Pause. No more errors. Oh, now it doesn't print. The pushes do not appear in here. So what if we print the warning instead of push the warning? Print stack purpose print error. Let's see how that goes. Pause. So we have more errors than matches. First one seems to happen around here. As expected. 234 matches. So probably for finding what is the error, we need to print this and see what is not matching as well. So let's dump out plus equal dump register and let's make this function. Dump register is going to return a string bar out equal string return out const registers equals and let's make an array and let's see the list of registers. Copy this paste here. So it is A, X, Y, P, SP, and nothing else, because we are not going to check the PPU. And the cycles. So for register in registers, so register ID bar register equals registers get register ID new. Let's assert register exists, and we can say out plus equal register ID colon, or maybe use format instead, 0, 1, or use S in here and formatting in here instead. And the arguments are the register ID and the actual value. So what happens if I run this? Yes, it should have a space after. So let's see, what do we get now? So this register does not exist with ID SP, and that is because SP where is the flag? Right, it's called stack pointer is just an integer. So let's remove SP from here and let's just add it manually. Out plus equal SP and this, and stack pointer. And it's percent stack pointer. Now it's going very bad. And why is that? So even in line 1, P is not matching, and that is because of the default value of flags. So let's go to reset, and it says the value of flags is OB. We could use 24, but what is 24? 24 is 1 like this, maybe. Pause. So no, it is not that value. So what was the value that was used in here? What did the register do on reset? What was it? CPU reset 100. No idea why. Pause. Now we got a clean start. So on line 72, it make a difference, and the difference is on the processor. And the error was caused by the push PHP. So what is 6F and what is 7F? 6F this, and 7F so the difference is this bit, the bit number 5, the bit that we are meant to not set. So F PHP, I suppose B is the one that we want to pause according to this. Let's see what changed now. Okay, now that this one passed the PHP on line 70 something. PHP passed, but this AND did not pass. And what is this AND doing? It's doing an AND between the accumulator Hmm. 39, yeah. X29 with register. Register was supposed to be zero before. And let's check is indeed register A. So why is A being set to 6F instead of 7F? This is strange. A was meant to be 0 before. But after this Okay, PLA is supposed to set the flag. Is that it? Wait a second. $6D. And what is $6D? So it is unsetting the negative flag. What is the second flag? Let me check. The 0 flag. It is unsetting the 0 flag. And why is that? PLA. P register not equal flag. It is popping the value and it is not negative. It should be a 0. Why is it? But it is set into the right value. So it was 6F. Why is it making this AND? So we have EF and 6F. Why is it turning into a 7F? No, wait. EF and 6F. It is supposed to be 6F. Indeed, it's supposed to be 6F. What happened in here? Is popping the value. Push at 6F, pulling 6F. But why is it 7F in here? Okay, now I think now I get it. So it pushes with fast. No, it pushes with true and then turns it into false. Okay. Let's try that. How does it go now? Okay, now it passes. And it stops in this part. Okay, lot of progress today. I think it's enough. We are not quite there yet, but we are making a lot of interesting stuff. So thank you very much for watching and staying around. And see you on next stream.